So digital twin, as the name suggests, so it is a digital model of the actual one, right? And there may be, sensors, everything, so which will be transferring IoT, and all the information from the actual will come to the virtual one. So in the actual, what will you require? You will require hardware, you will require software. Then only the actual, the virtual one, which is placed somewhere else on the computer, will display what the actual is. It could be for a vessel, it could be for a machinery, it could be for vessel designing, it could be for the port, it could be for everything, right? But mostly our in orals, he may ask you a digital twin with respect to the vessel only, but it could be with respect to the port also. So we'll do it that way, in a generalized way, right? So concept of digital twin. So what is it? It refers to a virtual replica or digital representation of a physical ship or marine asset incorporating. So you have to make it as realistic as possible. Real-time data and advanced simulation technologies. It acts as a bridge between the, imagine that you have a virtual model, you can walk through the engine room, you can see the engine also, you can see all the parameters of the engine also, exactly as what it is happening on the vessel in real time. So something like that, right? So acts as a bridge between the physical and digital worlds, offering numerous benefits, right from designing towards to the whole operation life, right? Throughout the life cycle of the vessel. We'll write down the advantages also, but just an introduction first. So digital twins enable your maritime stakeholders, including shipbuilders, ship owners, operators, to visualize and analyze ship performance and behavior in a virtual environment. Understand, like each equipment fitted with all kinds of IoT, all weather inputs, all, right? So everything is just what the real vessel is facing. You are having your model is facing the same thing. So by creating an accurate
Sir, what is this after seat performance and?
behavior, right?
Okay, sir.
Okay, in a virtual environment. So by creating an accurate uh, digital replica, they can monitor and simulate various scenarios. You don't have to do the actual thing on the vessel. You can simulate it here, see the effect, and then you do the same thing. You want to change the fuel index, do it here, see the effect on other units, then do it on board the vessel, right? Scenarios.
So this is applicable to autonomous ships also.
Yeah. Most importantly, it will be for autonomous ships. You require here IoT, right? Internet of Things. You require the sensors to transmit data so that your virtual, that replica has all the information what you would actually have on the vessel in real time. Okay.
Sir, where is this replica in a shop or in means in a factory or in shore?
It may be with the company if the company is operating the vessel. It may be with the shipyard which is designing the vessel. It may be a replica of the port itself, where the port authorities are looking at how to control the congestion of vessels. Okay.
So it is basically a software inside a computer.
Yeah, definitely. That is what it is. Virtual world, right?
Okay.
Yeah. So, and simulate various scenarios, access the impact of design changes, optimize operations, and predict maintenance requirements more effectively. So you get real-time insights. You have got, you need something, right? So you need hardware and software to be installed on the vessel. Then only your this digital twin will replicate the same thing. So you have you will require, as we said, IoT or Internet of Things will be required, and so direct streaming of data. So then all stakeholders can monitor vessel performance, fuel efficiency, CII compliance, right? So all can be taken care of by having this digital twin. And even in ship design and construction. So what changes are required on the model, then you do it on the ship, so you can optimize the same. So advanced technologies, IoT plus for analysis of all this data, what will you require? IoT plus cloud computing plus AI. Okay. So some features. Let's just write down features of digital twin. These are the key points, right? First one requires installation of both hardware and software on ship and a number of software systems for correct process simulation. You'll have to write all algorithms and all that, isn't it, to make the digital twin. Receives data from other external sources, also apart from the vessel. Example is with respect to weather, current, waves, So you have some weather routing, so that data is coming here, right? Provides, also uses ML, machine learning, so provides solutions based on historical data. So you don't have to go through the PMS to see that what was done last time when this problem came, right? So this is doing all this. Minimizes the risk of human error through large number of algorithms and accurate modeling. And can be used not only for making decisions in real time, but also for predicting events using ML, big data, and AI technologies. Okay. So this is obviously a more expensive solution, but then it also than the concept of what is your smart ship. But it is also more accurate. Okay with that? So,
sir, more expensive than smart ship.
yeah,
Smart ship.
smart ship. And if you're aware of what is a smart ship anywhere? No? Okay.
मतलब इसी को तो smart ship बोल सकते हैं ना सर?
Smart ship is less than this one, right? So smart ship relies on sensors, but does not require large number of algorithms and all that, right? And displays various indicators on special dashboard. Okay, so that is what it does. So not your digital twin, not having a virtual thing here, right? So this is a unified solution. Whereas in digital twin, you can see that you have a virtual model which is going to do everything. Smart ship will have smart sensors everywhere. All the data is coming, being displayed on a particular dashboard. Some computation is also happening, right? So real-time decision making, it is helping you, but it is not going into the into a separate replica kind of thing. Okay, so this is one step ahead, more expensive, but more beneficial also.